Assalamualaikum and hi. Today I'm gonna deliver a lecture on the topic FET amplifier design. Okay, this is a subtopic in chapter 3, FET AC biasing. I hope that you can refer to my PDF notes on this topic. In designing an FET amplifier, it means that the characteristic of the network is given, such as IDSS, VP, and AV. I hope you can recall back the procedure on design operation of FET during DC analysis in chapter 2. The procedure also will be applied for designing FET amplifier. In this FET amplifier design, both of the DC and AC analysis need to be done in designing the FET amplifier. One more thing to remember is the usage of standard value resistors are very important. We call that you have a standard value resistor table that we refer to find the values of resistor that is available in the market. In this topic, I will explain step by step how to design the amplifier by using this example. So we will go through this example so that you can see how to apply the design method. In this method, example, you see the circuit. This is a fixed bias, okay, fixed bias amplifiers, and with the FET, okay, because there is no resistor here. So this is the fixed bias, and then we have another here. Okay, the given information is AC gain of 10. So the question is determine RD. You can see in this circuit no value at RD, but we have IDSS 10 milliampere, VP negative 4, and YOS equal to 20 microsiemens. This example doesn't provide the VGSQ information, which is needed when calculating the GM. Hence, the DC analysis need to be performed first to determine the value of VGSQ. For a fixed bias configuration, VGS will result in VGS equal to VG minus VS, and in the circuit you see that at the RG, near the RG, there is no value for the VG, and then for the VS there is no RS. So VG equal to 0, VS also equal to 0. Therefore, VGS now is equal to 0. When we get the VGSQ in the previous calculation, now we insert this VGSQ in the GM equation. Okay, either you want to calculate GMO first, then you insert into GM equation, or you can calculate directly from this equation. So GM equal to GMO. GMO is 5 millisiemens. Okay, remember the unit is Siemens, and multiply with 1 minus VGS divided by VP. So we get VGSQ from last calculation is equal to 0. Therefore, we get again the same value, which is same with GMO, 5 millisiemens. Then we calculate the RD. Okay, RD you get from the 1 divided by admittance. This is admittance. Please don't use this value directly for the RD because it is different. R stands for the resistance or equivalent with the impedance, but Y is an admittance. Okay, so 1 minus 20 micro, so we get 50 kilo ohms for the RD. Next, draw the AC analysis equivalent circuit for the fixed bias. Okay, and we have to derive one by one the equation. The first one, take a look at the input side. We have V in here. Okay, this V in, and then is the voltage is parallel with the value at RG. So we can say this is the VG. Okay, here is VG, and here is VGS. VGS. So V in equal to VG equal to VGS. It has same value. Okay, then S here is 0. Okay, because no resistor, so we can say that VGS is equal to VG and equal to V in. Okay, now we know that the current here is GM VGS. So we insert this VGS with V in because we know that VGS equal to VG equal to V in. So this is the equation that we can get from this one. To get the voltage gain, so we don't need the value for Z in and Z out. So we go to directly find the voltage gain. So the voltage gain is from V out divided by V in. Previously, we already derived the V in. V in equal to VGS. And then by using, we find the V out. So the current is GM, negative GM VGS, multiply with the resistor, parallel resistor, RD, parallel with RD. Then we divide this one. So V out, the V in already cancelled inside this equation. So it become negative GM multiply with RD and RD. So we know that we want to find RD. Okay, we already calculate the RD, we calculate the GM, and AV is given. The example given, the gain is 10 here, which is this is AV, and then due to fixed bias configuration, which is common source configuration, the gain will be 180 degree phase shift. Means that there is a negative for the voltage gain. Here you get negative. So when you want to insert this 10, remember to include together this negative sign. So insert negative 10 in the voltage gain equation. Then insert all value that we have calculated before. Then we get RD equal to 2.08 kilo ohm. Then this is not finalized. Okay, you have to find the standard value resistor table and check for this value. So we get the nearest value is 2 kilo ohms.